example 2, we're going to now graph transformations of cosine. Again, we're only looking at stretches and compressions. We're not looking at vertical and horizontal shifts. We're going to be doing that in example 3. So for cosine, let's revisit the parent function of cosine. So we have cosine starting at its maximum, its amplitude. So remember with sine, we kept saying that sine started at its midline and then went up or down. Well, cosine is going to start at its amplitude. And it will either start at its top of the amplitude or the bottom of the amplitude based on whether it has been reflected across the x-axis or not. So before we draw transformations of cosine, let's write down that note about cosine is that any cosine graph, so the cosine graph, will always be starting at its amplitude. Now, remember, it might start at the plus or the minus of its amplitude based on whether it's reflected across the x-axis. Okay, so sine starts at the midline, cosine starts at its amplitude. So in example 1, we talked about the 5 points that we want to include on sine. Cosine, it's the same thing. We have those same basic points because sine and cosine have the same period. On the original function, we have those same basic points, pi over 2, pi, 3 pi over 2, and 2 pi. So it's just where the locations are is what changes. So notice that we hit the midline for cosine twice in the middle. We start at its amplitude and we end back again at its amplitude, and then the one point in the middle is at the opposite side of its amplitude. So that's the same basic graph that we're going to be graphing for cosine. And so this is exactly the same thing that we did with sine as far as setting up our amplitude, our tick marks, and everything is exactly the same as example 1. It's just when we go to actually graph the graph of cosine, we just graph a different shape. That's it. So in example 2a, we have cosine of 3x. So just a reminder, this 3 inside the argument is affecting the horizontal stretch or compression. So the amplitude was not changed because the coefficient in front of cosine was not changed. And so then the period is affected by a factor of 3. And so we're going to be reducing the period by a factor of 3. So our period is now going to be 2 pi over 3. So just again, so you can kind of visualize this, 2 pi over 3, if you think about it on the unit circle, is in that like second quadrant. So here's pi over 2 and pi. So 2 pi over 3 is going to be somewhere in here. And you can kind of see that if 2 pi from here to here is a full cycle, then a third of that would be right about in here. So what's going to happen is you're going to be fitting an entire cycle of cosine from 0 to 2 pi over 3. So it's going to look something like this in relation to the original cosine graph. It's just making sure that we get those 5 anchor points, is what I like to call them, by showing those on with the tick marks in our example on our blank paper. So like I said, same thing that we did in example 1. Before we actually draw the graph, everything's exactly the same. So we have an amplitude of 1, and then we're going to go down to -1. And then since we're starting at 0, because we don't have a horizontal shift, we're going to be starting at 0, and so we're going to be ending at the period of 2 pi over 3. So then this is where it gets a little tricky, making sure that you understand how to do your arithmetic with fractions. So I'm going to go halfway. So halfway, 2 pi over 3 divided by 2 would just be pi over 3, right? Half that. And then we're going to half that again. So half of pi over 3 is pi over 6. And to get the halfway mark in between here, some fractions are easier than others, and some people are better at fractions than others. So to kind of give you a mathematical way of doing it, this is how I do it. I think of, okay, if I start at 0 and then I go to 1 pi over 6, so each of these little sections is a length of 1 pi over 6. So then if I add another sixth, I get 2 pi over 6, right, which is pi over 3. And then I add another one, which is 3 pi over 6. And 3 pi over 6, we know when reduces is pi over 2. And then just to make sure that we have everything right, if I add another pi over 6 to 3 pi over 6, you get 4 pi over 6, which reduces to 2 pi over 3. So if you need to kind of do your fraction work off to the side, just to make sure that you get those tick marks right, then that's great. That's totally fine. So that's the hardest part. Now we're going to graph our cosine graph. So cosine starts at its amplitude. If we have a positive cosine, it's going to start at the positive side of the amplitude. If there's a negative in front, we'd start at the negative. So since this is positive, we're going to start at its amplitude of 1. And then we're just going to follow our sinusoidal curve. So we're going to go down to the midline, down to the -1, back to the midline, and back to the beginning. So remember, wherever you start in your cycle, you've got to end at your cycle at the same place, because that's showing that you've gone one period. So then we can graph our cosine graph, and that is our answer. Now, one thing that I want to make sure that you're not doing, because I will take off for this, make sure that your graph is curvy. I've seen some people get into the habit of doing something like this, where you're just drawing like straight lines, okay, what you see in my pencil. That is not correct. That is not the graph of sine and cosine. You want to show the curviness of sine and cosine. So make sure when you're drawing them, think, like parabolas kind of, all right, not straight lines. So just kind of a hint that I've seen some people do in the past. All right, so for part B, we've got two transformations now. We have the amplitude has changed as well as our period. We also have this negative, so we know we're going to reflect across the x-axis. So since cosine starts at its amplitude, it's going to start at -2, not at the +2. So just keep that in mind. Now the amplitude, remember, is the absolute value, so we have an amplitude of 2, but the negative just means we're going to start at the negative side. And then the period is going to be divided by a factor of 1/2. So in other words, multiplied by a factor of 2. So we're going to end up having a period of 4 pi. All right, so let's graph this. Our amplitude is from 2 to -2. And then we're going to draw our horizontal tick marks. So our ending point is going to be at 4 pi, halfway, 2 pi, halfway, pi, and then this one's quite easy to see what goes there. That would just be 3 pi. And now let's graph our cosine. So cosine starts at its amplitude, but it's reflected across the x-axis, so we're going to start at -2. Then we're going to come up to the midline, up to the maximum, back to the midline, and back to my starting place. So we just have a flipped version of cosine. So for part C of example 2, I actually want you to pause the video and do this on your own. So pause now, and do this on your own. And then once you restart the video, I will have the answer drawn for you, and I want to make sure that you did it correctly. So pause now. Okay, so hopefully you paused and did this on your own. So this is what the ending graph should look like. Notice for our period this time we had a factor of pi, so it actually canceled out that pi factor, giving us a period of just 2 without pi, and that's totally fine. So we ended at 2, and then we found our halfway marks, and this is what the graph of this should look like. Hopefully you got it right. Okay, so now that we've looked at sine and cosine graphs and horizontal and vertical compressions and stretches, now we're going to look at an example 3 when we look at horizontal and vertical shifts, which are a little bit more difficult, but we can do them.